Welcome to Engineering Studio with Dr. Mohammad Tahir. In the previous video, we have discussed about the limit states and design consideration for concrete footing. In this video, we will discuss the general procedure for footing design. So the first of all, we need to gather all input information such as the allowable bearing capacity of the soil, depth of foundation, support reaction, for applicable load combination, soil refill, and surcharge. So after getting these information, the applied loads, we need to decide the type of footing, whether it should be a raft footing, it should be a isolated footing, or it should be a combined footing. So at the initial stage, we can start with the isolated footing. So use service loads to calculate the required area of footing. So by using the service loads, we can calculate the required area of footing by considering the limit state of soil failure. So select the trial size and shape of the footing depending upon the area and other site specific requirements. So based on the area of the footing or the required area of footing, we can select the size, mean the width and length of the footing, as well as the shape. Whether it should be a combined footing, either it should be a isolated footing, it should be a combined footing with trapezoidal shape, or it should be a strip footing, raft footing. So we can again decide based on the required area as well as the site specific condition. If there is a chance of differential settlement, then we can again go for the combined or strip or raft footings. Okay, the fifth step is estimate the depth of footing, mean the thickness of footing slab. We need to estimate, so based on the punching shear requirement. So this will be decided based on the punching shear. So the size of the footing is decided based on the soil failure condition, and the thickness of footing is decided based on the punching shear failure, and the minimum thickness should be more than 250 millimeter. So we can estimate the thickness of the footing by using this expression where P, M, and Mx and My are the service loads and bending moments at service stage. Alpha S is a factor which is 40, 30, and 20 for interior, edge, and corner columns respectively. Fc prime is the strength of concrete used for the footing. So from here we can calculate this value H. So after calculating the depth of the footing, we need to calculate the effective depth, which is equal to D is equal to H, mean total depth minus clear cover minus diameter of bar. So here if we have a footing of slab and we have provided the bars over here, so we need to subtract this clear cover and half of the dia of this bar. Mean we need to subtract this much distance to get this effective depth, and this effective depth should be more than 150 millimeter for footing on slab, and it should be more than 300 millimeter for footing on piles, mean for pile cap. Using the factor load, calculate the design contact pressure. So after that we need to calculate the design contact pressure. So we will see in the next video when we will solve the examples for isolated footing and combined footings are the footing subjected to eccentric load, how we can calculate this contact pressure or net contact pressure. So after that, calculate the factor bending moment, one-way shear and two-way shear at the critical section. So the bending moment as well as shear forces are the shear stresses are calculated based on the factor load, while this thickness as well as the area is calculated based on the service loads. This is because while calculating the area of the footing, we use allowable bearing capacity. So when we are comparing the loads with the allowable bearing capacity, so in that case we need to consider the service loads instead of factor load. So the 10th step is check effective depth of footing for punching shear as well as for one-way shear, and then decide or calculate the amount of steel reinforcement in both the direction, and the minimum reinforcement should be more than these limitations. So these are the same as in case of slabs. So the minimum steel must be 0.002 BH for grade 300 steel and 0.0018 BH for grade 420 steel. In case of rectangular footing, determine the amount of steel required in the central band, as we have seen earlier. So we in the previous video that in case of rectangular footing, we need to provide some extra reinforcement, or we need to reduce the spacing of reinforcement, shorter reinforcement in case of rectangular footing in the central band. So decide the diameter and spacing of bars satisfying the maximum and minimum spacing requirements. So these requirements are similar to that of slabs. So the same requirement for maximum and minimum spacing will be applicable over here. Check bearing strength of footing and column and decide the required number of bars for dowel bars or as a dowel reinforcement. So we need to check for the bearing strength of column as well as the footing and decide the number of dowels. Check and satisfy all development length and lap splice requirements. So although we will cover this in the next or in some other topic under the heading development length, but while designing a footing, we need to ensure the development length of the flexural reinforcement as well as the dowel reinforcement. So if the flexural reinforcement is safe or have sufficient development length, then we can provide straight, or we need to provide the end hooks. Similarly, in case of dowel, either we can provide in the straight direction, or to ensure its development we need to bend it at 90-degree angle. So this will be clear when we will cover the topic of development length, that if the available length is less than the required development length, then we need to provide the hooks to ensure the development of bar. The next is design of isolated footing subjected to concentric load. So this will be covered in the next video.